Hello, students. Today we'll be working on a new unit. This is on statistical analysis. Today we're going to look at measures of central tendency, which would be the mean, the median, and the mode. And then we're going to look at measures of variation. So you may be thinking that you've done mean, median, and mode before, and you probably have. We are actually going to use a calculator on a website that will do a lot of the work for us so that we can answer some questions using the mean, median, and mode. So in this example that we're going to do today, I have some data that is up here at the top of the table. And I'm going to go ahead and have you access the website for this. So if you have these notes up, you can click on this, or you can copy and paste it into a browser. But when you do, you will get to this mean, median, and mode calculator. And if there is data already in there, you can just hit clear, and then you'll begin entering the data set. Now I'm going to have to go back and forth between the two screens for a little bit. So I'll try to remember a few of these. One nice thing, well, first of all, the data does have to be separated by commas. One nice thing is it will put the data in order for you. So what I'm doing now is entering the data. You'll need to do that when you're working on this example. And if a number is used twice, like the 30s that I'm entering now, it is important for you to enter both of those. And got just a few more to enter. And there should be, I believe, 21 pieces of data. So once you've got your data entered, you can hit calculate and see that it puts the data in order, which is a really nice feature. It lets you know how many. So if you knew that you had 21, this tells you that you had 21. Notice that it gives you the mean, the median, the mode, and then some other pieces that we are going to talk about. So the mean, we'll go ahead and round it to the nearest tenth. That would be 26.2. We can fill that in on your notes page. So let me get back to my pen where it recognizes that. Whoops. Sorry about that. So my pen, double check it again, 26.2. And then the middle number, the median, this would be, if you did have to calculate it by hand, this is the middle number when you arrange the numbers from low to high. So the median in this problem is 29, as it gives you there. And then the mode, the number that occurs most often. Now, this might be one thing that you have to pay attention to. The mode, it says, is 30. And so as you look there, we had 3 times where there was a 30. I did notice that this calculator puts all the numbers in the list if there is not a repeated one. So remember that mode means the one that's the most often. So on Math Excel, if there is not a number repeated, then that means there is no mode. So it is possible that you could have no mode. And that would be the one thing you'd have to interpret from the calculator that's on here. So this would be your information. The mean is useful when the data set has no outliers. We're going to talk about that word in a little bit, and determine how that is calculated. Basically, an outlier is a number that is either considerably higher or considerably lower than the rest of the data. So, for example, on this data set, if we would have had a score of 75, no other piece of data is anywhere near 75. And so 75 would be an outlier. So when the outlier is included in the mean, it affects the mean. When the outlier is included in the median, it has less effect because you're looking at the middle numbers and not letting that mean be affected so much. All right, so then the measures of variation that we'll look at, this will determine how much the data has spread. So the range, this would be the largest minus the smallest, and we can look and see that the range is calculated with this. So for our data, the range is 36. So that would be the whatever the biggest number is minus the smallest number. So if you look, it's that number minus that number. But the calculator did that for us. And and then you have what's called the interquartile range. So that takes your data and divides it up into 4 sections. And and then we would call those dividers the first, second, and third quartiles. So Q1, Q2, and Q3. And often, while we're at it, we'll go ahead and mention the minimum number. That would be the lowest number in the list. And we would also mention the maximum number, the highest number in the list. So let's go ahead and look at what those pieces of data are for our set. So the minimum is 0 and the maximum is 36. Let's go ahead and fill those in. So 0 and 36. And then Q1, Q2, and Q3. Q1 is 19.5. Let's go ahead and fill that in. So Q1 is 19.5. That means if we were going to rearrange our data from lowest to highest and then separate it into sections, 4 evenly matched sections, 19.5 would be the number that would make our first section division. And then 29 is Q2. So we've got that at the halfway point. Notice that the median is Q2. All right, so the median is the same as Q2. And then Q3 from our data is 33.5. So Q3, 33.5. And you'll be asked to give that information as you are working on your assignment. So you can get all of those things from this mean, median, and mode calculator. Now, as far as outliers are concerned, there actually is a way to calculate an outlier. The calculator that we've got here actually does that for us. Oh, I need to go back to the interquartile range. The interquartile range is the last thing you'll be asked about. Interquartile range is given to us on this calculator. It's 14, and it is the difference between Q3 and Q1. So I'm going to tell you how it's calculated, but it is calculated for you. So in our problem, the interquartile range, Q3 minus Q1 is 14. Now, back to the outlier. There is a way that you can calculate the outlier, and it's by taking Q1 and subtracting 1.5 times the interquartile range, and then that establishes a low cutoff. And you can then do the same thing with Q3 and add on 1.5 times interquartile range and calculate the high cutoff for the outlier. And that's what this calculator is doing. And it discovered that there, for this data, are no outliers. So sometimes you'll be asked about that. So in this data, there are none, either for the low or the high. However, I will say on your first homework problem, the calculator is going to tell you that there is no outlier, and that is true by calculation, but they're going to want you to choose the highest number. So make sure that you follow my instructions on the information on the work page. So those are our measures of variance that we can find from this calculator. We have 2 other measures of variance that we need a more specialized calculator for, and that's going to be for variance and standard deviation. And it says to be sure to select population, and I'll show you where that is. So I'm going to select this, and we'll go to this website. Now we're going to have to enter the data. I believe that I can just copy and paste it. So let me select this data and copy it and go to my other calculator and paste it. And then right here is where you have the choice to choose either sample or population. You are going to want to choose population for the calculations. This is what the data set is going to be based on from Math Excel. So you're going to find, after we hit population and we calculate it, that you get the 2 things that we were looking for there. Let's go back and talk about them. Variance and standard deviation are used to determine the distance from the mean. Variance is the average squared deviations from the mean. Standard deviation is the square root of that variance. So be sure that you're reading your vocabulary correctly. So variance is 77. Let's go to the hundredths place. 77.99. So getting back to here and the drawing tools. So the variance, 77.99. And then the standard deviation, which is the square root of the variance. And so we'll look up here, and that is 8.83. And again, we'll do the nearest hundredth. So 8.83 is what we can fill in for that. If you're at all curious, you can see the calculation right here. So it does show you if you're at all curious. Notice that the mean they've got here, and let's check and see what we put for the mean, 26.2. So we're in agreement on that. And then we have a couple of ways of graphing your data. One would be with a line plot. Now, I went ahead and put some boxes for you to label your data. So at the beginning, our data is test scores. So it said test data. So we could fill that in right here. These are test scores. And when you do a line plot, you are going to make X's for each one of the scores. And then that's going to let you see that you have the student scores here. I'm just going to write that up and down. Let's see. See if I can do that. Let me hold this a little bit differently. So this is students. Actually, let me put that number first. This is the number of students. And so what we'll do on this bottom axis is I'm going to go back to the mean, median, mode calculator where the data is in order. And we're just going to start listing that data. So 0, 13, 17, 17. And so I've got 0, 13. Now in this, we don't have to have a regular scale. We can just list all of our data. It's nice to have it in order. And you don't want to list it twice because we're going to use something else to represent that. So 19, 20, 24, and 27. Um, 29, 30, 32, and 33. And we're almost there. 34, 35, and 36 is the rest of our data. So 34, 35, and 36. And I believe in your homework you do not have to construct a line plot, but you do have to know how to read one. So now we're going to put X's for each time that we see this data. So for example, there's only one 0, there's only one 13, but there are two 17s. So I'm going to put an X for 1 0, an X for 13. Try to keep those even. And then when there's more than one, then stack up the X's. So there were two 17s. Then 19 and 20 and 24, those all just had one each. So 19, 20, 24. Then 27 There were 2 of those, 2 29s and 3 30s. So 2 27s, so we want to make that about the same height as we did the 17. 2 29s, and then 30 had 3, so you want that one to show up higher. 32 and 33 each had 1, so 32 and 33. And then we moved to 34. It had 2, 35 had 2, and 36 had 1. So 2 here, 2 here, and 1 here. So this would be a line plot of the data, and it asked what percent of the students, what is the percent of students passing? Well, you would need to know some other information, so I can go ahead and give you that this was a quiz that that was worth 36 points. So a passing score is what you would need to know, and it would take a 22 or higher for a student to be passing. So we want to talk about how you would calculate that. So we've got to find any scores that are higher than 22. Well, since we know there are 21, and remember, you can get that either by counting or looking at the fact that your number of scores right here said there were 21. So what you could do is count the number that did not pass. So 1, 2, 3, 4, 5, 6. There were 6 that did not pass. So that means that 15 did pass, or in other words, 15 out of the 21 students. 15 out of the 21 students did pass. Now, in order for us to know the percent, you're going to need to do, and I think you could do this on just a regular calculator. So we'll bring up good old Desmos to do this. And 15 divided by 21 gives you this decimal. To write it as a percent, you would move your decimal 2 places to the right. And if we go to the nearest tenth, that would be 71.4%. So on the notes, I'm going to write both the decimal and the percent. And so that would be 71.4%. I'll put that in the blank. Okay. So again, this was the number of people. There were 15 who had a 22 or higher out of 21 students. 6 of them were below passing. Okay, so that's how a line plot can help you see some information about your data. Okay, the other type of graph that you'll do is a box and whisker plot. And for this, we'll use the Q1, Q2, Q3. So the graph starts at the Q2, and so that was 29. So we'll draw a line not quite to the 30. And this is Q2 to get us started. And then we're going to draw a line where the Q1 is. So Q1 is at 19.5. So just to the left of the 20. And we're going to connect those, so try to make them the best you can the same height. This is Q1. And then Q3, which is 33.5. So just in front of the 35. And so that third one is the Q3. Now, this is what makes the box. So Q2 in the middle, Q3, Q1. So notice that there's a little bit more of the data between Q1 and Q2 than there is between, not more of the data, a bigger distance in the data between Q1 and Q2 and between Q2 and Q3. Then to get the whiskers, we will plot the minimum score, which was a 0, and we'll just put a dot for that minimum score. And then we're going to plot our maximum score, which was a 36. Now, that's just after the 35 there, and you'll have to do a little estimating. And then to those, you draw a line. This would be the whiskers. So this is the minimum, and this is the maximum. And so we have the length of the box is proportional to the interquartile range. And remember that interquartile range was just taking Q3 minus Q1. So this is proportional to the interquartile range. And the vertical line inside the box is the median, which is the same as Q2. So the vertical line inside the box is the same as Q2, which is the same as the median. So that should help you determine some of the questions